Hello! In this video, we will cover section 2.3, which is on visualizing categorical distributions. Categorical distributions can be visualized in the same way as numerical distributions. We display the value of the variable or category and the number of times that it occurs in the data set. The two most common methods for presenting categorical data are the bar chart and the pie chart. The bar chart looks similar to a histogram, but there are some important differences. To explore the differences between a bar chart and a pie chart, we can use a data set from a summer introductory statistics course at UCLA. The data set contains the class year for the students. Here's the data set on the left. You can see we have the students and then the year that they are at the college. And then we can go through and turn that into a frequency table. So we have the class options here on the left, and then the number of times that those options occur in the data set on the right. So once we've done that, we can go through and create a bar chart. A bar chart contains a bar for each category. The height of the bar is proportional to the relative frequency of that category. The vertical axis can either contain the frequency or the relative frequency. Okay, so here we have a bar chart that contains the data from the frequency table on the previous page. The bars are proportional to the relative frequency or the percent that those bars make up of the whole. Okay, so the way to look at that is that this bar right here is 35% of all of the data. This bar here is 25% of all of the data. And the difference between their heights is the difference between 35% and 25%. Okay, they're proportional to the size that they make up of the whole. Okay, now on the left here, we have the axis and it's labeled with relative frequency. A bar chart doesn't have to be relative frequency. It could just be frequency. Okay, so we could just have this unknown, the height of that, instead of being labeled 35% or 0.35 proportion, we can look back, what should it be? What could it be? It could be 7, right? So we could have this be 7 as the height. And then the seniors, how many seniors are there? We can just jump back. There are 5. And so we could label the height here as 5. So you could have either frequency or relative frequency over here on the left axis. The order of the bars in the bar chart can be adjusted for natural order or for emphasis. Okay, so it's more art than science when it comes to the order that these are placed in. So there is no fixed order. The left one below is by age. So you could consider that to be maybe the natural order. And then the right is in descending order by frequency. So that type of bar chart has a special name. It's called a Pareto chart. A pie chart divides up a pie into slices. The area of the slices is proportional to the relative frequency of that category. The pie chart below contains the data from the UCLA statistics course. Okay, so the idea is that the slices here, the unknown slice, right? So what did we say that was? That was, let's go back, 35%. So this is supposed to be 35% of the area of the entire pie. Right, and the same thing goes for the other. I think the next one, the seniors, was 25%. So this is supposed to be 25%. So the relative size of the slices is supposed to be the relative amount that they make up of the entire distribution. Right, and so that's how you can go through and create a pie chart. Right, so if we're going to compare the two, although pie charts are very common, they are not commonly used by statisticians or in scientific settings. Why is that? One reason is that the human eye has a more difficult time judging the relative size of slices of pie than the height of bars. So if you were to go through and look at this, it's harder to tell that this is, the difference between this slice of pie here and this slice of pie is about 2/3 compared to looking at the height of the bars, right? So you kind of, maybe 2/3 is a little bit hard, but like, let's say we're comparing the unknowns and the juniors, right? So the unknowns is about double the size of the bar. You can just see that visually by looking at the bar heights. It's actually maybe not quite double, but you get what I'm saying, right? So you can just see that by just eyeballing how tall these bars are. But if you go through and try and do that here, if you're trying to compare this slice of pie to this slice of pie, it's harder to tell that this one, that the unknowns is close to double the size of the juniors. It's easier to compare the height of bars than it is to compare the size of slices, right? And so that's why you see bar charts more common when with statisticians or in scientific settings, where accuracy is really important. You see pie charts in less formal settings. All right, let's look at a homework example. According to an organization, there are 5 leading causes of preventable death in a region. They are shown in the attached graph, where HPB is high blood pressure, TU is tobacco use, HPG is high blood glucose, PA is physical activity, and OO is overweight and obesity. All right, so we can see here we've got a bar chart with that, and it is labeled, and this time it is not labeled with relative frequencies, it's just labeled with frequencies. All right, so what is it asking us to do? Estimate how many preventable deaths result from high blood pressure. Estimate how many preventable deaths result from tobacco use. We're asked the question, does this graph support the theory the greatest rate of preventable death comes from overweight and obesity, as some people have claimed? And then this is a bar chart with a special name because of the decreasing order of the bars. What's the name? Let's go through and do that. So we're gonna have to jump back and forth because I'm probably not gonna remember each of these questions as we do them one at a time. So the first one is high blood pressure. How many preventable deaths result from high blood pressure? So let's jump back over here. Which of these is high blood pressure? It's the first one. How many preventable deaths are there? Well, we just want to figure out the height of the bar. And it looks like it's about 7.2, maybe. Around there, around 7.2. So there's about 7.2 million deaths per year from high blood pressure. What's the second question? Estimate how many preventable deaths result from tobacco use. Okay, let's jump back over. Tobacco use. So which one of these is this? The second one is tobacco use. The height of that bar looks like it's at 5. So there'd be 5 million preventable deaths from tobacco use. So the third question, does this graph support the theory that the greatest rate of preventable death comes from overweight and obesity, as some people have claimed? No, it would not support that theory. Why? Because overweight and obesity, that's the shortest bar. There is the least number of preventable deaths from overweight and obesity based upon this bar chart. And then this bar chart has a special name. It's a special name when you have decreasing order of the heights of the bars. So what's the name when you have a decreasing order of the heights of the bars? That's called a Pareto chart. And all of the, maybe we should just look at this page because I did manage to fit the answers and the chart on the same page. But yeah, it's actually supposed to be 7.3, 7.2, 7.3, close enough. 5 million does not support the theory, and it's called a Pareto chart. Okay, so that's the video. Thank you for watching, and I'll see you next time.